Right, so in this video we're in section 1.3, and this is just a brief verbal explanation of why some statements can be called vacuously true or true by default. And so I've just copied down the truth table. This is one that you should have memorized for the conditional proposition, P implies Q. And a lot of times I get the question that all three of the rows seem to make pretty good sense except for this second one. Why is it the case that when P is true and Q is, I'm sorry, I said that wrong, is this third row is the one that people question a lot of times. Why is it the case when P is false and Q is true, then the conditional proposition is true? Well, one explanation is that logic is kind of just like a game, and in order for the game to work, this has to be the case. A more real-world example might be something that I wrote here. I wrote an example of a conditional statement. Now, this is just hypothetical, so don't get excited about this. This isn't anything that's actually going to happen. It's just for purposes of illustration. But it says, if you get an A in discrete mathematics, that's the if statement, which is P, then I will pay you $1,000. Okay. Well, what happens if you don't get an A in mathematics? If you don't get an A in mathematics, then the if part of the statement is false. That matches this third row. The P is false. And so really it doesn't matter what happens after that. If you don't get an A in mathematics, this statement doesn't apply to you. But that doesn't mean that what I said was a lie, right? So that's why we say by default the statement has to be true. So when the hypothesis is false, the statement doesn't apply, but that doesn't mean that it's not true. So in order for the game of logic to work, this has to be the case. So you see in these last two rows, when P is false, automatically the statement has to be true. I don't know if that helps, but that's why we have statements that are true by default, or your book also calls those vacuously true.